All right, so we did exponential equations yesterday. Now we're going to do log equations. So you're going to need to try and remember those properties that we did last section, because that's going to help you kind of condense some things down. Now, the only thing we have to pay attention to is you're only allowed to have certain numbers when you plug into a log, right? You can't take the log of a negative number, okay? You can't take the log of 0, okay? So if the number that you get, you're going to have to check. You're going to need to plug it back into the original equation, and then if you get, you know, a negative number or 0 inside what you're taking the log of, that solution is just not going to work, okay? Because it would be undefined for that particular value, okay? So before we would just solve it out. We didn't really have to worry about what we were getting. For any equation that has a log in it, you do need to pay attention to, you know, your answer. Okay. So if I have log base 3 of x plus 2 is equal to 4, what's one way that I could solve it? Eamon? Right. So write it as a exponential. Okay, so that would make it right. 3 to the 4th is equal to x plus 2. So we know 3 to the 4th is 81. So that would make x 79, right? So you just want to make sure, when I plug in 79 into here, does that give me a positive number? Obviously it does. So that is good to go. What's another way that you could solve this? Log base 3 of x plus 2 equals 4. What's another way that you could do it? Yeah. You could. Might be more difficult than what you really want to do. What do you have to try and get rid of? Log base 3, right? What is the opposite of a log base 3? Exponential with a base of 3, right? So we can use that property where I can raise both sides to whatever this power is, right? So what you do to one side, you do to the other. So you make it 3, right? So now this is your exponent. So 3 to the log base 3 of x plus 2 equals 3 to the 4th power. Now these two things are right next to each other. This 3 and this log base 3 will cancel each other out. And you'll be left with x plus 2 is equal to 3 to the 4th, which, like the last one, you would get 79. Okay? So that's just a different way that you can do these. All right? So you want to isolate the term that has the log and then pay attention to what the base is. You can raise both sides to that base to help you eliminate the log term. It's kind of like peeling back a layer. You got to get the log layer out of the way before you can go any further. Okay. All right, so for the first one, all right, you want to get the term that has the log expression to be by itself. So anything that's on the outside, you want to try and get rid of, okay? So that would tell me I should get rid of what first? You know? 4, right? So that would give me 3 log base 3 of 2x is equal to 12, okay? Then you can divide the 3 over, right? That'll be 4, okay? So now it's like we have the last one, right? How can you get rid of the log base 3? Yeah. Right. 2x is equal to fourth, which you know is 81. So x would be 81 over 2. All right, so you have to make sure that 81 over 2 gives you a positive value when you plug it back into the original. So 2 times that, obviously, is going to make it positive. So that's yeah, that's fine. Okay, so for the second one, I have 2 log expressions. I want to get down to 1. I need to try and condense this. So, yeah. Right. Since they're being added together with the same base, you can multiply them together. Good. Okay. So how next you would do what? Yeah. Good. So the 10 and the base 10, right, go away. So you're left with x plus 2 times x minus 1 equals 10 to the first, which you know is 10. And then from there, you're just solving a regular quadratic equation, right? So you got x squared plus x minus 2 equals 10. X squared plus x minus 12, right? Get everything on one side, and then factor it again. So you got x plus 4, x minus 3. All right, so again, you got to plug both of those back into your original. Do they work for the original? So if you plug in negative 4, right, what do you get? Negative 4 plus 2 is negative 2. You can't take the log of a negative 2. So that goes away. And then if you plug in 3, you get 3 plus 2 is 5, which is fine. 3 minus 1 is 2. That's also fine. So your only answer would be x equals positive 3. Okay. All right, so you know how before, if we had 2 exponentials that were the same base, what did we say was true? The exponents were equal, right? So if you're taking the log, same base, right? They have the same base on both sides. What do you know then is true? Yeah. Right. Yeah. So this is then going to be equal to that. Right. So you don't even need to worry about the log terms because they are going to, since they're equal, you can set their expressions equal to one another as well. So then you just have, again, a regular quadratic equation. So put everything on one side. 4. Do they both work? Right. Positive 1 is not going to work. So your only answer would be negative 4. Yeah, so if you plug in 1, 1 squared is 1 minus 3, which is negative 2. So you can't do that. Good. All right, again, here, you're trying to use your properties so you can condense down, right? So I see that I have coefficients out front. What can I do with them? What? Make them exponents, right, good. So you have log base 4 of x minus 5 squared minus log base 4 x minus 5 cubed. Right. Now, if you have the same log expression, right, and they're being subtracted, what can you do with this term and that term? Divide it, right? Good. So log base 4 x minus 5 squared x minus 5 to the third equals 1. Okay. Yeah. Good. Right, the x minus 5s are going to cancel. Okay. Now to get rid of the log base 4, you would good. So that would give me 1 over x minus 5 is equal to 4, right? So what do I do next? Multiply the denominator over, right? So that would give me 4x minus 20. 21 equals 4x. 21 over 4. Okay. So does that work? 21 over 4 is roughly how much? It's a little bit bigger than 5, right? So if I do 21 over 4 minus 5, that should still be positive. That should still be positive. So that's your only solution. Good. And I'm going to skip E because we've kind of already done it. What are we going to run into here for letter F? Yeah. Right, you got to change the base, right? I can't condense them down right now because they are two different bases, right? I have log base 10, and then I have log base 100. So in order for me to condense it, I got to change one, right? So if I change the first term to be log base 10, right? You take log of what you're taking the log of over log of the old base. Right, so log of 100 is going to give me what? 2, right? So you have log of x squared divided by 2. Now what can I do with that 2? Since I'm dividing by 2, I'm really multiplying by 1/2, right? More work than what you want to do. So what else could you do with the 1/2 though? Yeah. Okay, yeah. So you're saying take this and move it down? Okay. So then when you have 1/2 times 2 of log of x, that just gives you log of x, right? And then when you bring down that, right, so after all that work, right, now you're down to 2 log expressions with the same base, right? So now since they're being subtracted, you can divide, right? All right, so to get rid of the log, right, what am I going to raise on both sides? 10, right? So x over x to the third is going to give me 1 over x squared, right? And then if you raise both sides to 10, it gives you 10 to the 6, right? Now, I'm trying to figure out what x is, right? So I need to get rid of this fraction, right? So what you guys can actually do, if you ever see something like this, if you switch this, right, if you take the reciprocal of that, what does that give you? X squared over 1, right? So if you flip this, you'd have to flip the other side too. So that if you flip the other side, that turns into what? 1 over 10 to the 6, right? So if you flip them, you get 1 over 10 to the 6, right? So then you square root it. And what is the square root of 1 over 10 to the 6? 10 to the third, right? Okay, so which one are you allowed to keep, though? Just the positive one, right? So if you take the negative one, right, 1 over 10 to the third, if it's negative, right, if you square it, it's going to be positive. But then if you cube it, it'll be negative, and that won't work. Okay, so your only answer would be 1 over 10 to the third. Good. Okay, so for the last couple minutes of class, I would like you guys to be working on like part 2 of the practice from the notes. So that's, I think it's on page 5. And then, whatever you guys don't finish, you can bring back on Friday.